Okay, so we have this question right here. It says we need to find the final speed for the object, right? So we have S, we have the angle, and that's it. It says from rest and frictionless slope. So we have S is equals to 20 meters. We have U, which is 0 meter per second. And we don't have time, we don't have acceleration, and we need to find speed. Okay, so let's see what we can do. First, let's identify what is actually happening here. The object is going down the slope, right? But how is it going down, right? Like something must be helping this box to go down. There's no frictional force. None of the force is provided by us. Then how it's going down? So it's very simple. Weight is actually helping it to go down, right? Weight is providing the acceleration. So you can see this weight. Now let's draw its components, right? To understand furthermore, like which of the component, either is the sine component or the cos component. Let's first figure that out, okay? So in order to draw the component, imagine this line to be a straight line, okay? Then you will be able to draw the components. So in order to reach, this is your resultant, right? The W is your resultant line, okay? So you need to reach here. You can only use up, down, left, right. So first I will go down, okay? And then I will go to the left side, okay? Let me try it a bit more correctly. This and this, okay? So this is your 90-degree angle and this is your 23 degree. Opposite to this angle is always sine theta. And yeah, you will go down and then you will go left, okay? And this is your resultant line. The one which is not your resultant line or sine theta is cos theta, okay? So this is your cos theta. Now, what we need to do is we need to figure out which of the component is helping. Sine theta is helping because it is helping it to go to the left side or down the slope, okay? So W sine theta is helping it for the box of acceleration. It's helping the box's acceleration, okay? Now, if you just calculate this, you know that your unit is still newtons, right? How can we use this as our acceleration? We can use the formula of F is equals to ma. Net force is equals to the mass times the acceleration, right? So your net force, or basically the box that has the acceleration, is W is equals to W sine theta is equals to ma. And if you expand W, it is mg sine theta is equals to ma. Now cancels out. Now you're left with A is equals to g sine theta. Okay. So we have acceleration, we have initial velocity, and we have s. So we can use the formula v square is equals to u square, equation of motions, v square u square plus 2as. So you have to find v. So we can make this square come here. It's square root. Now you know that your u is basically 0. So we can just remove that and you're left with 2. A is g, which is 9.81 times sine, and theta is 23 degree. Sorry, 23 degree. And then you have s, which is 20. Okay, that's it. So this is your expression here for final velocity. So you have t2. Option A says 2 times 9.81 times 20 times cos. Everything with cos is wrong. And then you're left with C and D. So let's check C and D. So you have one of the difference is 2 and 0.5. 0.5 is wrong. So your final answer is C. Simple as that.